Hey everyone, welcome to the AI show. I am Cassie Breviu. Super excited to be hosting today. We have lots of good stuff for you. We are going to be talking to Jingya from Hugging Face. We're going to be looking at how to optimize models with ORT Trainer, some really cool demos. And then we also have Prathik here who is going to be talking about how ORT Trainer works. So before we get started, why don't you all tell me where you are coming from? I love to see that when I watch the AI show. I'm usually lurking in the comments if I'm not hosting. So it's really cool to see how many people come from different places. I am in Minnesota, actually. Jay from sunny Seattle. Sunny question mark. Is it not sunny there? I'm not sure what the weather is like there. We're actually really sunny last week, which is weird for Minnesota in April. We had 87 degrees and sunshine in April. And then yesterday it was 30 and a snowstorm. So in April, Minnesota weather, you never know what you're gonna get. So that's kind of crazy. Cool, where else do we have people coming from? Oh, the other thing that we're going to talk about. So if we have time, after we look at the Hugging Face Optimum library with transformers and ORT training, I have an update on the Stable Diffusion project I've been working on, which I'm excited to share. If you guys saw the first one, oh gosh, it had to have been at least a month ago, maybe two, that when I was still working on it and it wasn't working. We have someone from India. Welcome. What's the weather like there? I love hearing about the weather in other places. If you've ever met a Minnesotan, you'll know how much we love to talk about the weather. So rained over the weekend in Seattle, but bright and sunny on workday. Why has it got to be like that? I like to hang out in my sunroom when it's sunny out during a workday and work in there, because then I feel like I get to at least feel and enjoy the sunshine. And I know even Seattle weather, you got to enjoy the sunshine when you get it, right? So you don't get it all the time. India is 45 degrees Celsius. We have South Africa. Hello, welcome. I don't have the cool, I forget what the device is that Seth has where he can like write on it and show the kind of cool things that we're going to be working on. I'm not that cool. I need to get some better devices. But I think we are ready to jump in and let's see what we're going to be doing. Oh, there was one other thing I was going to say. Sorry, forgot. Fake out there. I was looking on LinkedIn today and I saw that Hugging Face posted, so their transformer library, I don't know if you're familiar with it, we're going to see a cool demo from it today. Apparently it is getting really close to 100K stars on GitHub. And when it gets there, it will be the second ever open source AI project to reach 100K stars. That is really cool. So I'm going to ask y'all to go check it out, star it, and be part of their history, right? That is like, I think that's amazing. So, and it's totally deserving because, as you'll see, it's a really cool product. All right. Okay, so for real, we'll get started and we'll jump in. Hey everyone, welcome to the AI show. I am Cassie Breviu, and you are not going to want to miss this episode of the AI show, where we are going to be talking to Jingya from Hugging Face, and she is going to show us how we can use Optimum and ONNX Runtime to speed up our machine learning training. Let's jump in. Hey Jingya, thanks for joining.
Hi Cassie, hi everyone.
How are you doing? Tell us a little bit about you.
I'm doing great. So I'm in the Paris office of Hugging Face. So I'll introduce myself first. My name is Jingya. I'm a machine learning engineer from Hugging Face optimization team. And I am one of the developers as well as maintainers of the Optimum library that we will talk about today.
Fantastic. I know I'm super excited to learn more. It's also just a really cool name, like Optimum. I think Hugging Face does a really good job of making cool names for cool products that they build. So tell us a little bit about what Optimum is and why someone might use it.
Sure. So I think audience might be more familiar with the Transformer library. So Transformers is an open source library of Hugging Face, with which we made the state-of-the-art machine learning models more accessible. And the Optima library actually is an extension of Transformers library. So it provides a set of performance optimization tools to help users to train and run models on their targeted device with more efficiency.
So I can take my models and I can basically use different tooling that Optimum has in order to improve the performance and also to leverage different types of hardware, right?
Yeah, exactly.
Awesome.
So in Optima library, we have multiple modules to help users to achieve the most of their hardware. And ONNX Runtime is one really important module of the Optima library. It is fully open sourced and it offers training API as well as inference API to accelerate training and inference.
Cool. So these are some of the different pieces that are wrapped into Optimum. And generally, without Optimum, you'd have to go get these packages yourself and maybe do some configuration. So Optimum's kind of packaging it for you, right?
Yeah, exactly. So for example, let's take the trainer of Optimum as an example. Is inherits the trainer of transformers. Of course, user can do the configuration themselves. It's really free, but we have also some configuration already set up. So if you want to use it, it should be really easy to use. Yeah, so now we will talk a little bit more about the training API integrations of ONNX Runtime in the Optima library. So if you are already familiar with Transformer library, you might have seen or used the trainer API, which support feature complete training loop and evaluation loop with some extra features like mixed precision training, distributed data parallel, the zero redundancy optimizer, things like that. And it has really good integration with other toolkits in our Optima, in the Hugging Face toolkits, in the Hugging Face ecosystem, with Transformer library, diffuser library, if you are interested in stable diffusion model. And you can just pull models from Hugging Face Hub really easily and push the trained model back to your repo if you want. And but what's different from the trainer API in Transformer is that in Optimum, the ORT trainer, instead of using PyTorch backend, it will use ONNX Runtime under the hood to achieve the acceleration on training. So ONNX Runtime offer a lot of optimization techniques features. For example, the computation graph optimization, including like constant folding, nodes elimination, nodes fusion, things like that. It offers also a really nice, efficient memory planning. It do a kernel optimization, and in the Optima library, we have also integrated the Fused add-on optimizer implemented by ONNX Runtime, which actually batches element-wise updates on the model's parameter in just one or fewer kernel launches. And also we have like more efficient FPIC16 optimizer support if you are interested in mixed precision training.
So my workflow here then is I would use the Hugging Face Transformers API and I would pull down a pre-trained like model that I want to fine tune, right? And so then I would grab that and then I would use ORT Trainer to speed up my training to allow me to get that fine-tuned model that I want, but to also get the results faster.
Yeah, exactly. So actually, when we develop the ORT trainer API, we really pay attention to the ease of use of this API. So the user experience is pretty much similar to trainer if you already use it, and you can just replace trainer by ORT trainer.
That's nice. That's super nice. And I think Hugging Face in general, all the libraries do a really good job of simplifying, I think, complex tasks, and then also making consistency between different tasks that you're doing in different APIs. So it's nice to know that the trainer that they've used before with using ORT trainer, it's going to feel very natural and like their same process if they've done it before.
Yeah.
Fantastic. So are we going to look at how to use this? You have a demo for us, right?
Yeah, exactly. So today I will go through a demo using ORT trainer to fine-tune the DeBERTa model on a question answering task.
Great. Let's take a look.
We will start by setting up the environment. So before launching the training, we have actually two conditions to meet. The first thing is that we need to check if we have at least one NVIDIA or AMD GPU in our machine. For example, here I have access to an NVIDIA Tesla 4 GPU that I will use for the demo today. And the second condition is we need to ensure ONNX Runtime training package is installed and correctly configured in our environment. For this, I would invite you to take a look at our Optimus documentation, in which we provide a step-by-step guide on helping users to correctly set up the environment. And another option would be just go to Optimus GitHub repo, in which we updated Docker files with the latest ONNX Runtime release. For example, today I actually will launch the demo with a container built by the latest Docker file, which will use ONNX Runtime 1.14.1. Besides ONNX Runtime, we need to also pip install Optimum, of course, and other Hugging Face open source libraries that we will use in this demo. Once we have the environment set up, we can dive into our demo. We will start by preparing the dataset. Here we will use Stanford question answering dataset for fine-tuning Microsoft's DeBERTa-based model. We will use Hugging Face dataset library to download the dataset and then load the metric that we will use a little bit later for the evaluation. We can have a look at what the data looks like. So both training and validation sets have a field of the context, the question, and the answers to the question. Then we will do some pre-processing on the dataset. We will use Transformers tokenizer to tokenize the text. We will need to set up some arguments like max length to truncate the context, like docstride to set up some overlap between two parts of the context to avoid the case where the answer just locates on the splitting point. Now we put everything I just mentioned under a pre-processing function, and we will apply it to our training dataset. After the data preparation, we can now start the training. We will first load the pre-trained DeBERTa-based model from the Hugging Face hub with the auto model for question answering class. Then we are going to configure the training arguments. Before so, just let me download a config file from Optimus repo, because today I will use Deep Speed Zero redundancy optimizer with ONNX Runtime. So Zero will reduce model states redundancy, thus reduce memory usage. Here we use Zero stage 1, which partitions the optimizer states. So just to mention, actually, ONNX Runtime training, it supports Zero stage 1. So we can combine the power of both for gains on both computation and memory. And that's what we are going to do today in this demo. Now we download the config, we can instantiate the training arguments. Here, if you are familiar with transformers, you might have found that we just replaced training argument class with ORT training argument class. One thing I would like to mention is that for the optimizer, here I use ORT fused add-on optimizer. It is an optimizer implemented by ONNX Runtime and then integrated in Optimum. It can batch element-wise operations into one or few kernel launch. Then we can instantiate the trainer. For transformers user, so it will be just replace trainer class by ORT trainer class. But you might also have spotted one extra argument, which is the feature. So just like trainer in transformers, ORT trainer also has not only the training loop, but also the evaluation loop. You can either evaluate with PyTorch backend or ONNX Runtime backend. Here, the feature arguments is actually used for exporting PyTorch model to ONNX format, so we can use ONNX runtime to run the inference. Now we can launch the training. So I launched the training a few hours ago to save some time for the demo. Here, you can just use trainer.train function to launch the training and then save the model. One thing I want to point out is that today for the demo, I actually just use one single GPU, but you can, of course, use multiple GPU to launch the test in distributed manner. You can either use torch run to run your script directly with distributed data parallel, or if you are using a notebook, you can also use Notebook Launcher in Accelerate library of Hugging Face to do that. Once the training is finished, we can now use the trainer for evaluation of our fine-tuned model. And just like preparing the training dataset, we will also need to do some pre-processing on the validation dataset. Here we will apply the prepare validation features function to our validation dataset, and then use the predict function of trainer to get some raw results. And then we will apply another post-processing function. And with the matrix in the dataset library of Hugging Face, we will be able to compute the evaluation. Here it will be the ratio of exact match and the F1 score. In the last section, we will jump from training to inference. As I mentioned, Optimum supports not only training with ONNX Runtime, but also inference. So for deploying our trained model, we can load the pre-trained model with subclasses of ORT model. Here it will be ORT model for question answering. We set the export to true, so under the hood, the PyTorch model will be traced and converted to the ONNX model. And we will tokenize an example what's the benefit of using Optimum library. And we do the inference with the ORT model that we just loaded. It will tell us the answer is it can accelerate the training speed. So we just show the demo. It's more about how we can use the ORT trainer. And here we have done also a benchmark to show the performance of ORT trainer. I mean, it's a sense of using it, right? So this benchmark actually was run on an NVIDIA A100 node with 8 GPUs. And we took PyTorch 1.14 as the baseline. You can see in the graph, actually the columns in gray use ORT as the backend for training. And the columns in blue also combine the ONNX runtime with DeepSpeed stage 1. As I said, it helps on partitioning optimizer states for achieving extra gain on the performance. And we got really impressive results on the benchmark. We can see that we achieve up to 40% of increase on the throughput when using ONNX Runtime standalone. And we can achieve from 39 to 130% of increase in the throughput when combining ORT trainer, when combining ONNX Runtime backend with Deep Speed Stage 1.
So that's cool. Putting all of these things together in order to speed up training. So it saves you time, also probably saves you money, right? Being able to increase these training loops with these different tools. So you went over a lot in that demo. We saw you getting the model from transformers. We saw the data set. You went and grabbed the tokenizers and did all of the pre-processing that you needed in order to then fine tune that model with ORT trainer. And then we even got to see the full end-to-end with getting the export to ONNX with the flag that you set after training, and then seeing the inference of that model. So we got to see the whole picture of how we could go in there, use transformers, use Optimum, use ONNX Runtime Trainer, and inference to improve the speed and get the model that we need, right?
Yeah.
So is there some places where people can go and try this out for themselves?
So you can find the notebook in our GitHub repository and also other training examples that we provide in the repository.
Awesome. So I'm sharing those links below. They'll also be in the chat. Make sure you go check those out. Try it out for yourself. Where can they go to learn more?
So we really encourage everyone to read our blog post that we put on Hugging Face blog post, that we introduce in detail how by using ONNX Runtime we can achieve better performance, and we put some snippets to showcase how it can be easily used, and also the benchmark result. You can also find it on the blog post.
Awesome. I'm a big fan of the Hugging Face blogs. I think they do a really good job of really making complex things very easy to understand. And I think that's actually really hard to do. And so I think that checking out that blog and even other blogs on Hugging Face is a great place to go just to learn more about transformers or state-of-the-art models, and then also this Optimum tool, which is really cool. So thank you so much for joining me today on the AI show. Really cool stuff. And yeah, anything else you want to share?
Yeah, thanks for having me for the AI show. I think what we all want is that users to try it out and get us some feedback about it. We can definitely discuss on GitHub repo, or you can file us an issue if you have some feature request. We are really happy to help.
Awesome. That sounds great. Thanks so much.
Thanks.
Awesome. Okay, so now that we saw that amazing demo, we learned about Hugging Face and transformers and ORT trainer, we are going to welcome Prathik and Jingya live to the stream. Thank you for joining. So I hope you all have been thinking about questions to ask these engineers that have been working on these products that you've just seen, these amazing open source tools. And so I'll start with one. We saw a little bit about how ORT trainer was working, kind of a high level. Prathik, could you tell us a little bit more about how it's able to improve the training speed to those levels?
Yeah, absolutely. The way it works under the hood is during the first training step. So when you're processing your first batch, we go through and we use a ONNX exporter that's already built into PyTorch to export your Python code into a computational graph. From there, we have preset optimizations that fuse different nodes together based on some known patterns, stuff like, softmax layers gets exported as like 4 or 5 nodes. We compile it, or we reduce it down to 1 node, and we write one super optimized kernel for it. We have efficient memory planning, for example. We make sure that all of our inputs are contiguous arrays as opposed to sparse arrays, as well as we have a floating point 16 optimizer that gives more memory savings than traditional mixed precision training. So these are some of the things that we do, among others, that allow us to get the optimized training speeds and memory efficiency.
Awesome. And is there certain models, like we saw a transformer model, from the Hugging Face Hub. Are there certain models that ORT Trainer works better for, or considerations people should make when trying this out?
ONNX Runtime was definitely built with the transformer model in mind, just because of the parallelization that comes with the model architecture. Although we have some experience fiddling with some more traditional architectures like CNNs and RNNs, they may not work out of the box because it's definitely built for transformers, but it can be done.
Okay, cool. So the demo we saw is kind of like a standard process for using Optimum ORT Trainer and transformers together in order to fine tune transformer models for different tasks. So that's kind of the idea of where it really shines and performs well.
Absolutely. Jingya did a great job with that demo.
Yeah, it was so good. Thank you. Thank you so much. Let's see if anybody's asking questions. Now's your time. I don't see any yet in the chat. Jingya, you mentioned that diffusers and Optimum are now working together. Can you tell me a little bit more about that?
Yes, actually, since the Optimum 1.7 release, we also add support of inference on diffuser models with ONNX Runtime backend. So if you are familiar, so actually it's an integration with diffusers as well as ONNX Runtime. So if you are familiar with diffusers library, you can just replace stable diffusion pipeline with ORT stable diffusion pipeline.
Awesome. And I know what diffusers is, but in case people don't, why don't you give us a quick high level of what diffusers is?
So diffusion model is a really trendy since last year. So basically, by giving a text prompt, you can. So first, you will use a text encoder to encode the text prompt, and then with the UNet model and VAE encoder, you will have an image generated with your prompt, which is super cool.
Yeah, so diffusers are these text-to-image models, and diffusers library from Hugging Face makes it really easy to do inference with different ones and use different schedulers and things like that. So it's a really cool. It's like the amount of like code you actually have to write to use diffusers to do this really complex thing is very minimal too. So it's a neat library, and it's cool to see that it's integrated. Another thing, since I'm still not getting any questions, so I guess I just get to ask all the questions. I saw that you have a Docker container for different configurations for the ORT Trainer and Optimum, but I think there's some like other Azure cloud configurations that you can use, and I think Pratik, you wanted to talk a little bit more about that, right?
Yeah, absolutely. So if you do take advantage of Azure ML and work through an Azure ML workspace, there are built-in containers. They're called Azure Container for PyTorch, or ACPT for short. And they come with ONNX Runtime already installed. Hugging Face has a great documentation on how to install it, but if you don't feel like going through that process, ACPT comes with ONNX Runtime already installed and hooked up with everything that you need, as well as some additional optimization libraries like Nebula for checkpointing, and some other stuff. But that container is put there as a general start space for anyone who wants to just quickly spin up a model in the cloud and train it.
Awesome. So lots of different ways to use these different libraries and tooling, depending on if you're on-prem or in the cloud. You can leverage different tooling based on that. Well, I think those are all my questions, and I'm still waiting for some from here. Anybody ever try out some of this or have any questions around transformers or just Hugging Face in general? I saw someone mention they asked what a Hugging Face model was in the beginning, and I wanted to just clarify. But I think since we had the demo, Hugging Face is a hub for lots of different types of models, and then it has all these different libraries that you can use to then interact and download. So there isn't a Hugging Face specific model, but you use Hugging Face's libraries to download them from the hub. And I think that just want to make sure that clarification was there.
Yeah, so in Transformer, we have a lot of easy to use API to help downloading those state-of-the-art model and help training, running inference on it. And of course, we started from a transformer-based model like BERT, and then we also expand to not only focus on NLP, but also computer vision, audio, multimodality, things like that.
And I believe someone is saying something about Linux and Windows, and I think this works on both, right? There's not, it's cross-plat. Or is there a preferred? Is one preferred over the other?
It's cross-platform, but Linux is probably preferred.
Okay, cool. That's kind of what I thought, but wanted to clarify that. Cool. Anything else you all want to share since we're not getting any questions?
I want to share, like, there are a lot of ready to run examples on both the Optimum library and the Transformers library. So even though Jingya put together a great demo specifically on DeBERTa, there are all kinds of example scripts for any sort of task from image classification to speech recognition already there for you. So, peruse those and make changes based on your specific application, and it should be very easy to use.
That's great. Having good examples in the starting point is important to be able to use things. So I'm also sharing that link below again for people to go check it out. All right. Well, I think then we will say goodbye. Thanks again so much for joining us and adding in. Oh wait, we do have a question now. Can you model empathy with Hugging Face? I mean, you can do sentiment analysis. That's kind of a philosophical question.
Yeah, I think sentiment analysis was what this person was getting at.
Okay. So I'm like, you could go really, kind of high level there and go into the weeds. But yeah, so sentiment analysis. Yeah, do you want to speak to that for what models you have available?
Off the top of my head, I'm not sure, but their most traditional NLP architectures can be used for sentiment analysis. I know that.
Mm-hmm. And transformers too. So like the BERT model, I know I've used that one, and I've fine-tuned with the emotions data set from Hugging Face to create a sentiment analysis model. So it's definitely possible to create that and fine-tune with different data sets. If you have a specific data set that you want to fine-tune a base BERT or something, you could do that.
And on the off chance that...
Sorry.
No,
so encoder models are widely used for those kind of sentimental classification tasks. And if you are interested in sentimental classification data set, you can also find it on Hugging Face Hub.
Nice. And on the off chance they were talking about image classification, we recently added an image classification example to Optimum. So if you come in with your own data set with, faces and emotions, you can easily fine tune any of the state-of-the-art image classification models on empathy detection.
Awesome. Great. Okay. Well, thank you so much again for joining. They said that's great. Thanks. So I think we answered their question. And yeah, thanks again. But everybody else stay on because we're going to play with some other things that I've been working on. Okay. So I love when we get to show these amazing open source tools that people are building. Diffusers is so cool, and Optimum, and then ORT training. And they're like putting all of these things that are really difficult to do and making them really simple by like wrapping the tools together and simplifying the process. So I love to see those types of things being done for the community. So let me share my screen now so that we can take a look at what I have been hacking on lately. Let me get this shared. All right. So I think I might need to make that a little bit bigger. There we go. And then the other thing I wanted to show is here's the Transformers library, so that we were talking about. You can go into Hugging Face and check out their other awesome libraries that they have there. Here is the Optimum one that they were talking about as well. And you can go in and check out those as well as we showed those short links. But one thing that I've been playing with is diffusion, stable diffusion. So that, like we talked about the diffusers library. And I had mentioned, or I had actually done a show when I was still working on this project. So a lot of times when I build something out, I kind of figure it all out and then I show it. But on the last show, or the last time I was on, I kind of showed the broken version of Stable Diffusion as I was kind of reverse engineering it off of one of Hugging Face's blogs, actually, from diffusers. And I now have it working and wanted to kind of share an update there. So this is a text to image model. And what I did is I took it and I recreated it in C# so that you're able to do inferencing in C# while leveraging ONNX Runtime. So I think we've talked a lot about ONNX Runtime training. We also have ONNX Runtime for inference. And that inference library is available in multiple languages. So you can grab your model that you've maybe you fine-tuned with RT Trainer with Optimum, and then now you want to use that model in C# or in C++ or JavaScript. And so this particular project, I wanted to see if we could recreate some of the logic to run Stable Diffusion. And let me pull up one of their blogs here to show you what that looks like. And actually, this is written up in the ONNX Runtime docs as well that I wrote. Go to inference with Stable Diffusion. Oh, there it is. Okay. So we also have it written up here, and you can go through this tutorial, but essentially you get this text prompt, and then images are created after going through this. So this kind of talks about the high level of how it works. If you go to the diffusers blog from Hugging Face, they have a really great one here that goes into detail about how it works in their diffusers library, and then just how Stable Diffusion works. So I was able to take that and then recreate it here. And so I'll just kind of walk through this, and still watching the chat. So if anybody has questions about this stuff, let me know. Love to talk more about it. So for this one of the things I did is I set up a class library that has all of my Stable Diffusion logic so that I can just import that. And so then my consuming project really doesn't need to have that much logic. So I added a Stable Diffusion config, which gives me some of the different parameters I need in order to run this model. One of the other things you need to do is download these models from the Hugging Face Hub to do inference as well. So those aren't included in this project, but you want to go ahead and download those, and then give the path to where they're stored. Because you can leverage different hardware providers for inference with ONNX Runtime, there's an enum that I created that allowed you to kind of easily switch between the different execution providers that you want, whether you want to use CUDA or DirectML to leverage GPU. The CPU you can use, but it's going to take a lot longer. So it's possible, but with the FP32 models that are out there right now, the size, it takes a little while for it to run. So if speed is something you're looking for, you're going to want to use the GPUs. But here we're just doing some configuration on the height and width, the guidance scale, the number of inference steps, and then the execution provider. And then we're also using ONNX Runtime extensions. And I want to take a minute to talk about that, because if you haven't seen them, this is a new project. GitHub Runtime from ONNX Runtime. Oh, no, that's not what I wanted. So one of the hard things that comes around when you're trying to do different inferencing in different languages is you'll find like a lot of the pre and post processing. So getting your data in the right format and creating your tensors, and then the same thing, and then sending those in and then getting them out, and then doing again that post processing and getting the result from that resulting tensor. That can be really difficult and time consuming when you aren't using some of the pre-built tools that are in Python. And even with them, sometimes it can be a time-consuming process. So one of the things that we started working on is these ONNX Runtime extensions, which allow you to serialize pre- and post-processing into an ONNX model. And whether that is part of the model that you're using for inference, or it's a separate model, which I'll show you in the Stable Diffusion like we're doing, And so this is under active development now. You can definitely go try it out. And there's some kind of minimal information here, but essentially you add in the extension, and then that might have different tokenizers, or you'll want to create that and then import it, which I'll show you how you do that. So I want to call out this project that we're working on because I think it's super important for just making model portability and making it easier to optimize and deploy your models in for different scenarios and solutions. So right now, because it's still under development, I have to build and add the DLL right into my project. But eventually there'll just be a NuGet that you'll grab. And then this is the clip tokenizer. So this is actually the tokenizer that I'm using, which is a clip tokenization, which is what you need for converting your, I think the simplest way to think about tokenizers is it turns words into numbers, right? And so this is taking that input text and creating a tokenization of it, which we then use to create an embedding. So if we want to take a look at what that looks like, let me open Netron here. And so that they're going to be different types of pre and post processing, and there actually are already different ones in the extensions that you can run and use. But let me open this model up. Hang on, gotta find it. So here is our clip tokenizer. Is that kind of small? Let me. Hopefully that's a little bit. Actually, wait, I will make it super big. There we go. So you have your string input, your tokenization, and then your outputs. Okay. And if we take a look at this, so this is where our string prompt would come in. It would get tokenized with the clip tokenizer. And I think we could even look at how that works in, if I can find it. That's the question. But the clip tokenizer script to create that is part of this library. And tools. No, yeah, I don't know where it is off the top of my head. I'd have to search. So we'll skip that part. Or is it in here? No. Well, there's different tokenizers in here, and like I said, we're still building it out, so it'll be easier to find. But that is one of the tokenizers that I'm using now for, in order to be able to tokenize, because the clip tokenizer isn't available in C# that I'm aware of. And so in order to even be able to run this in C#, we have to be able to tokenize our input. So that's the config. And also these, the number of inference steps and guidance scale, and these are all defaulted in there in the config itself. So you really could just create this config and add in the different paths for the models that you download to your models, or however you want to do that in your project. But I include them in here just so people are aware of them and what they're doing. So then to actually inference, all you have to do is send in the prompt, the config, and then all of the logic that I created for inferencing this in C# is in this class library. So if I jump in to this, we will see that the first thing we need to do is this text processing. So in the text processing class, let me know if that's big enough, if anybody can't see that. I think it looks big enough from my side, but if you have any problems, I can make that a little bit larger. But then you're sending in the string prompt, and ours was, let's see, a fireplace in an old cabin in the woods. And from there, we need to pre-process our text. And so there's a lot of different things we need to do in order to pre-process the text, like I was talking about, in order to get it to work. And so the first one is tokenization, which we were just talking about, right? So I'm adding in to my session options, which are my ONNX Runtime session options. I'm giving it the path to my ORT, and then being able to then now leverage ONNX Runtime extensions or custom ops, which is how ONNX Runtime extensions work, is through custom op. And then able to create my tokenization inference session, and then able to tokenize that output by running my tokenized session with the string input, running that model I just showed you, and then I'm getting out the tokens. So I'm grabbing the input IDs here, and then returning that back. And then I also have to add in some padding since it's expecting 77. So that's all this is, just looping and adding the blank space padding. So this part is the blank tokens. So this is part of the classifier free guidance, I believe. I can't speak to that really detailedly because I was really following how the Hugging Face implemented it. And this is one of the things they did. So in order to get just an unconditional input, I literally am just creating a blank token array and returning that. And then once we have that, we need to go into our text encoding. So this is one of the models that you're going to download, one of the text encoding models. So if I were to, I'll zoom in on this in a second. Hang on, let me get it open there. So you can see the models. So I have my text encoder. I showed you the tokenizer, and then our UNet model, which is going to go through our inferencing steps to diffuse the image. And then the actual decoder model here. So after we go through the loops of the number of inference steps, which I'll show you, to diffuse the latent image that's created, then we send that result to the decoder, and that creates the image that is returned. So those are the models that you'll want to grab from the Hugging Face Hub. And so one of those is that text encoding model, which I just showed you. And so that's what this is doing. It's grabbing it and encoding it into that latent state so that we can go back. And so if I go back up to my preprocessor here, we're getting our text embedding, and I'm going to be returning that now back to the inference step. So that's just the pre-processing part of the text before we go into it. So as you can see, like those can be a lot of different steps. And the more that we can kind of start to add those into the model or add them into their separate own pre-processing ONNX models, it makes it really starts to simplify the process of deploying your models. So then we have the scheduler. So this was something when I was still kind of like reverse engineering last time, we were trying to figure out on the scheduler what it was doing, because basically like high level what's happening. In fact, let me show there's a good graphic for this, what's happening on dev blogs. So what's happening at a high level is you're getting that. So what we just saw is this part here, this text processing. Once we're getting that tokenization and encoder, that's getting sent to the UNet model. And then this is our denoising loop, which runs for however many steps we tell it we want it to. And then this is the random noise image that is also an input. So these are our two inputs to our UNet model. And then this goes through the scheduler piece. And the scheduler piece was something that took me a minute to kind of reverse engineer. But basically, let me find it. I found a really good text to explain it here. So the pipeline denoises an image by taking random noise. So we saw that the latent random noise at the desired output. And then each time step the model predicts. So the model's predicting the noise residual. And the scheduler is predicting a less noisy image. So this is the loop that is happening until the end of the inference steps has completed. And so that part for me, when I was trying to figure out what the scheduler is actually doing, I think that that sentence right there really kind of clarifies how the two pieces kind of come together in this inferencing loop, denoising loop. So if I go back to here, so this is the first scheduler that I implemented. And I think I even have some line numbers, like from where I was using it from the Hugging Face thing. So just to kind of show you, this is from their diffusers library that we were talking about. And then this is one of the scheduling algorithms. So I was looking at how they implemented it in Python, and then implemented that in C#. So I implemented that one, and then I had some feedback from people saying it doesn't work well for an int8 quantized stable diffusion model. And so we now have a second scheduler that I also implemented based on the Hugging Face diffusers library. And the other thing, so if you look, there's more than just those two, and they have a really good blog post on how you can think about the different schedulers and the different ones that are available. So I would definitely check out this if you want to learn more about the schedulers themselves. So this will kind of show you the different ones that are available, but the ones we have work for a lot of different scenarios. And yeah, so those are the two that are implemented. Basically, it's a lot of math. I just leave it at that. But yeah, it's a lot of math that goes through and denoises. Okay. So let's go back to, where were we? We're in the inference here. Okay. Oh, that's not what I wanted. Here we go. Still no questions yet. If people have questions, feel free to ask. Okay, so then once we have our scheduler, we're going to set those time steps, and that's based on that number of inference steps, which we set in the config, which I defaulted to 15. So the more inference steps, the more time it takes, but it's supposed to create a more clear picture with more inference steps, but I think there's kind of a happy medium. It's one of those hyperparameters you just need to play with and figure out what works for what you're trying to do. So we set the time steps. In fact, I wonder if I can run. So the thing I'm kind of concerned about running this is it takes a lot of resources. My Razer laptop, it has an 8 gig GPU and it pretty much maxes it out when I run it. So I'm slightly concerned to run this because I feel like my video might cut out, but we'll try it right at the end. We still have like 5 minutes left here. So I'll finish talking through it and then we'll try running it and see if my computer can handle streaming and running Stable Diffusion at the same time. So from here, we are getting our scheduler time steps, the random seed, we're just creating a random. And then from there, we're taking that and we're generating the latents, which we saw in that image, so the static image. And this is an implementation of the torch.random function to create the latent static image that is in the input. And then for the session options, I created this helper in the config that's going to set up how to use the different targets. So you set up the enum to say if you want to use CUDA or DML. And then from there, it will set up the session options and return them based on what you want. So like if you want, to enable graph optimizations, there's a lot of different session options too. Like I'm not using all of them here, but I did different things here, like appending the CPU execution provider to the DML so that certain ops can be run on CPU and GPU, just because that's how it kind of optimizes and speeds up. So you want to append both just so that it can get the most performance. And then that's the same with CUDA here. So it's kind of just doing some of the, you could easily just set this up yourself, but I just added that kind of that feature in. So that way, when you have to call each session each time, you don't have to set that up each time. You can just call it and grab it and it'll return what you need. The other thing to note for NuGets to the right now, the DML brand or the DML NuGet and the ONNX Runtime GPU one, you need to install one or the other. So pick whether you want to be using the DirectML EP or the CUDA EP, and then install the appropriate packages in your consuming project. So then from there, we're creating our inference session with the UNet model. We're adding in those sessions that we just created. And then from there, we're doing the loop. So this is the loop if we went back to the, let's see, look at this cat, so cute. Okay, sorry, distracted by cute fluffy animals always. So here's that loop that we were talking about that calls the scheduler and gets the output and loops through. So we're creating our model input. We're scaling that which is one of the functions in the scheduler. We're creating the UNet model input. So if I go look at this, this is just giving all the tensors, which are the input labels that the ONNX model is expecting along with the tensors objects themselves. So getting short on time here, so I'm going to go a little quick through the rest of this, but we're running inference on our UNet model. we are getting that result. We're taking the noise prediction and the noise prediction text. We're performing guidance based on some calculations from our scheduler, and then calling scheduler.step, which is the step from that denoises and returns the previous sample. So this is the kind of that scheduler function that will be in every single one. So your process is to perform guidance, call your step, and then it loops through the number of time steps until it gets the result. And then from there, we are going to post-process, get our image, and return it. So I went kind of fast there because I want to try to run this and see if we are able to see it work. So then convert to image is just, we're grabbing the tensor, converting it to an image, and writing it out, and then we'll print out the path. So let's go ahead and run this. Although, what is it saying? Shouldn't be any changes. Did I break something? Let's just double check this quick. Yep, I did. Why did I do that? I guess I want to undo this change. There we go. Okay. Yeah, no, we're good. Right? Okay. Well, let's go ahead and run this. And so when we run this, we're going to be taking in this input, and then it's going to output the image. And this is going to take a minute, and we'll see if my computer can handle streaming while running Stable Diffusion. Living on the edge here. Okay. So here it's printing out my my text prompt that I asked. There's the tokenization from the clip tokenizer with the ONNX Runtime extensions. And then it's going to get that seed. It's going to create the latent image. It's going to go through that full process that we saw. And then we'll start seeing it once the inference steps start. We'll see it print out kind of information as it goes through each step. Well, it doesn't look like I've cut out yet. So this is good. It's going to work. Good job, computer. Actually, I shouldn't say that too soon. Oh, yeah, no, we're going. Okay, so here's each step of the 15 inference steps. And you can see as the process. And then now it's on the last step. And so it's going to do the decoding step. It's going to create the image. It's going to save it to an output. And then we'll see the path. All right. So now I can grab this path. Grab a new Explorer window. Actually, I probably could have just done window R, but there's this too. And here is the image that was created. So it's super cool. You can go play with this if you want. It's on my GitHub, and you can play with all different types of prompts. And the class library now, I'm working on that as a NuGet, so people can just go grab it. And then at that point, you'll be able to just do the pretty simple inference here. So we are out of time. Thanks for hanging out with me today. I always love when I get to do the AI show and share stuff that I'm working on and enjoy like the really cool things that the community is building. So all the different open source products. And then let me show you what is going to be next week. Hang on here. I've got to pull this up because the AI show is weekly, which means there's more good stuff next week for you to check out. So next week is going to be using R with Azure Machine Learning. So R, that sounds like it's going to be pretty interesting. And there's two things. Making Enterprise GPT real with Azure Cognitive Search and Azure OpenAI Service. So that sounds awesome. Make sure you come back next Monday and hang out with us again. Thanks so much.